Imagine this. As a member of a space exploration team, you will land on a planet far away from Earth. It's a beautiful blue and green planet. There is air and water. The conditions were supposed to be right. But the moment you take your first step, you're thrown to the ground. It's like carrying a weight many times the weight of the Earth. This time, we'll be looking at what would happen to humans if they landed on a planet with gravity 10 times stronger than Earth's. Let's simulate such an extreme world from a scientific perspective. First, let's quickly review what gravity is. The force that objects with mass attract each other is equal to gravitation. On Earth, all objects fall at a speed of 9.8 meters per second. If the gravity on Earth is 1, what about on other planets? For example, Jupiter's gravity is about 2.5 times that of Earth. But this simulation is not about that. Gravity, a planet of 10 g. Here, a person weighing 60 kilograms will weigh 600 kilograms. Now, you will put on the latest gravity adaptive suit, the G-frame, and embark on an exploration mission. Planet name, code name, Thalamus X. Gravity 10 times that of Earth. There is an atmosphere, oxygen, stable temperatures, and water. The only problem is gravity. You slowly step out of the lander and take your first steps. At that moment, my knees buckle, my back buckles, and my chest tightens. The human body cannot withstand this weight. On Earth, a normal weight of 60 kilograms is enough to stand and walk. But in a 10 g environment, that becomes a 600 kilograms load. Leg bones are unbearable, fractures. Muscles cannot move due to the weight. Compression of the spine, difficulty breathing, and nerve paralysis. NASA research has shown that astronauts' muscles atrophy after just a few weeks in zero gravity. Conversely, if gravity is too strong, the strain on muscles and bones increases dramatically. What happens to the heart? It takes 10 times more force to pump blood throughout the body. Standing up can cause blood to not reach the brain, resulting in loss of consciousness. Even when lying down, internal organs are compressed, making breathing difficult. Too much gravity also inhibits lung expansion. Shallow breathing and inadequate oxygen intake. The brain becomes confused by the lack of oxygen, leading to hallucinations, dizziness, and eventually coma. So let's say you wear a special gravity-resistant suit and you adapt it to some degree. But the next problem awaits. Unable to walk, can't run, jumping is not possible. Your body is heavy as lead and you can barely crawl to the ground. What about plants and animals? If gravity were too strong, tall trees would not grow and everything would evolve to crawl on the ground. So what would happen if there was a civilization on this planet? Buildings become lower and flatter. What about transportation? No wheels, underground transportation? What about animals? They have extremely thick bones and are muscular. Flying creatures? No. Flight is impossible. Even if civilization develops, it may not be the intelligent life we imagine, standing and walking. In fact, there are stars in the universe with high gravity. Super-Earths, rocky planets larger and heavier than Earth. 3 to 10 times gravity. Neutron star, gravity 10 trillion times that of Earth. It's impossible to even stand, let alone exist. Even if it's impossible to actually visit these planets. As science advances in the future, we may one day be able to explore using robots or remote controls. A planet where you can't even stand. The limits of our humanity and the boundaries of our imagination are in plain sight. Gravity is the silent force that supports our lives. But if that were to change even a little, all the laws of physics and everyday life would collapse. If you were to stand on such a star, your first step may be your last. Thank you for watching until the end. Please subscribe and like the channel. So, stay tuned for next time.